Behavior is also known as method, action, procedure, function, subroutine, and it means a small block of code, or maybe a large block of code, which defines an action that an object can do. Here's an example. We looked at this before. There's a function called addition in this calculator, and I can use that to add up two numbers. Now, you'll notice that whenever a function is defined, I say what the return type is. In this case, it returns a double. Now, that's great, but if I don't want it to return something, then I would not put the return statement and I would use the word void. Void means what it returns is essentially null or nothing. So in this case, as I said before, the return type has to agree completely with the value that you return back to the user. And if it doesn't, a good compiler will tell you that that's not going to happen and it's not going to compile. It also includes the visibility of that function or method. Again, public, private, undeclared. We'll look at those scopes in a second. And whether or not it's static. If it's not static, then you omit this word. Don't say it. It's worth mentioning as well that a function or a method can be overloaded. In other words, I might create, this might be double add, and I take in two parameters, 1 and 2. I might create another public static double add, another function with exactly the same signature of all of this, but with double A, double B, and double C as well. So it has 3 parameters instead of 2, and that's perfectly feasible. And Java at compile time will, whenever I call that add method, if I pass in 3 numbers, then it'll automatically call this version. If I pass in 2 numbers, it'll call this version. Now, parameters in Java are passed, well, if they're objects, then they're passed by reference, or value of reference. If they're primitives, they're passed by value. And what that means is that if I pass on the left-hand side, if I pass in an object, which is a cup of coffee, and I pass it into the fill cup method, then even though during that method, if I fill that cup of coffee, then it will also be filled in the variable that refers to it, where I called it from. In other words, if I pass my coffee into a method, and I do something to it there, those changes will be permanent. They'll take effect. Whereas if I use a primitive variable, if I pass, for example, if I pass an int, and the int is equal to 5, say x equals 5, and then I say fill cup x there, well, whatever I do here will not be permanent, because it will not affect the original variable back here. Because things are passed by value if they're primitive, not by reference. And whatever happens here, the only thing that's passed in isn't the x equals 5, it's just the variable or the value 5. So what to take from that is that objects, when they're passed in by reference, or are passed in by reference, and any changes to that object will be reflected in the rest of the program. Whereas primitives that are passed into a method, they're passed by value. Whatever you do to change that variable inside that method won't have any effect outside that method. Here's an example. This is a primitive where I say x equals 1, and I call the increase method of x, which comes in here, and it increases that variable. So it's actually, what's arriving in there is 1. A is 1, it's increasing that. A is now equal to 2. But when I come back from that method back here, x is still 1. It hasn't been affected at all by the change that's happened here because it's a primitive and it's been passed by value, so it always stays the same. The only thing that's changed is this temporary value of a, which has been created here. On the other hand, when I'm passing by reference, I'm going to make a new person class. I'm going to call it Ken, and I'm going to call its change name method. So it gets passed in here, and I change the name to Peter, and then I finish off and I pass control back here, then first name of the P variable is now Peter. It's been changed. It was changed here, but it takes effect here as well because it's been passed by reference, not by value. And again, I mentioned the visibility of that method. If it's a public method, if I specifically say public, then it's visible by everybody, all other classes, whether they're inside that package or not. If I say protected, then it's only visible within that class, that package, and anything which subclasses or inherits from a class in that package. If I don't have any modifier at all, if I omit that, then it's the same as protected. And finally, the safest one is if I call it private, then it's only usable within that class, which is what most of methods should be if they're not meant to be used. So let's have a quick look at what we've just done. Methods are also called functions, procedures, actions, subroutines, subprograms. They can be public, private, or protected. If you forget to put in a modifier, that means that they're visible to all other classes in the same package or folder. Methods can return, well, primitives, objects, or nothing at all if they're void. And if they are void, then you shouldn't use the return keyword in them at all. And if you do use the return keyword, it should correspond with the type that you've defined at the top of that method. Methods can be overloaded, i.e. the same name and a different number of variables. The return type of a class has to agree with the statement. But here's an interesting one. If I have a class called student, and I have another class that inherits from that called IB student, well, in that case, even though I have an instance of IB student, I can still pass that into a function which receives a variable of student, which I think we'll see a little bit later on. So you can generalize, i.e. you can pass into a function the superclass. A static method is, you can think of it as being stored within the class, not within the object, and it can be called without even making an instance of that class. So even before I create a student, I can say something like student dot get report list, or whatever the method is. A static method refers only to one copy. In other words, a static method can only refer to static variables. It cannot refer to non-static variables. And there's a good reason for that. If I'm calling a static method, then I may not even have created an instance of that class yet. So how could it assume that an instance variable exists? And even if it did, it wouldn't know which one to refer to. So basically, the rule is a static method can only refer to static variables, whereas a non-static method can refer to any variables. A non-static method, like I said, can access any variable. Java passes arguments. If they're primitive, it passes them by value, and if they're objects, it passes them by reference. So an object will change everywhere. A primitive variable will only change temporarily inside that function.